Its surface is mysteriously covered with a pattern of dark spots, patterns that here on Earth are almost exclusively linked to living organisms, to microbes and bacteria thriving in their environments. But there's something extraordinary about this particular rock. It didn't come from Earth. It came from Mars. NASA's Perseverance rover recently discovered this rock, and just yesterday, during a highly anticipated press conference, scientists made a stunning announcement. This could represent the strongest evidence yet of alien life on Mars. This very well could be the clearest sign of life that we've ever found on Mars. We've heard bold claims like this before. Potential biosignatures detected on distant exoplanets, organic molecules floating in Venus's clouds. But something feels different this time. So let's dive deep into this discovery together and separate fact from speculation. Earlier this year, I had the privilege of visiting NASA's Jet Propulsion Laboratory, the birthplace of Perseverance, to discuss humanity's ongoing search for alien life. The patterns I'm showing you now, these are precisely the formations that NASA scientists told me they were hunting for. If their analysis proves correct, we're witnessing a pivotal moment in human history, a potential answer to the question that has haunted us for millennia. Are we truly alone in the universe? I hope you're prepared for what's coming. Our journey begins in a place called Jezero Crater. NASA deliberately chose this landing site for Perseverance because geological evidence suggests it was once hospitable to life. Billions of years ago, this crater held a vast lake, multiple rivers carved to the landscape, carrying flowing water along with all the essential chemical ingredients needed to support living organisms. But today, Mars tells a very different story. The planet is dry, cold, and barren. That's why Percy, as the team affectionately calls the rover, is searching for fossils, the preserved remnants of ancient life that might have flourished when Mars was a warmer, wetter world. On June 9th of last year, Perseverance ventured into an ancient inlet channel, and something immediately caught the science team's attention, a slab of hardened rock that stood out from its surroundings. They maneuvered the rover closer. What they discovered was breathtaking. The rock's sample appeared to be covered in countless tiny dark spots, along with larger circular formations scattered across its surface. The team quickly nicknamed these distinctive features leopard spots and poppy seeds. While these patterns might appear unremarkable to the casual observer, they immediately set off alarm bells among NASA's team of geologists. Adam Steltzner, who served as Perseverance's chief engineer and currently leads the Mars sample return effort, explained the significance. On Earth, very similar kind of markings have been observed, and they are often linked to microbes, essentially a fossilized record proving that the mud was once teeming with life. If we saw them here on Earth, we'd say, "Oh, that's done by biology." But seeing it on Mars, the implications were staggering. Everyone was understandably excited. So the team immediately sprang into action, deploying Perseverance's entire suite of scientific instruments to analyze the sample from every possible angle. Given the profound importance of what they might have stumbled upon, the team made a critical decision. They would drill into the rock and preserve a sample for future, more detailed analysis. You see, one of Perseverance's primary missions is to drill and collect rock samples, carefully storing them for a future mission that will retrieve them and bring them back to Earth. Keep this in mind. It becomes crucial later in our story. And so they drilled. The rover extracted a cylindrical core sample and sealed it inside a specially designed metal tube. The team nicknamed this precious sample Sapphire Canyon, and it has since become one of the most valuable specimens ever collected on another planet. We are taking cores with Perseverance, and we've had some cores that appear to give us potential ancient biosignatures. Percy even captured a selfie immediately after drilling the sample. You can see the freshly drilled hole in the rock in the image. Little did the team realize at that moment that when they fully analyze this rock, their findings could potentially alter the course of human history forever. Did life actually arise on Mars? It's an enormous question. Yeah, if life arises everywhere it can, that paints a vastly different picture of the universe than one in which life only occurs extremely rarely under highly specific circumstances. But before we race ahead and declare that we've definitively found alien fossils, we need to proceed with caution. History teaches us an important lesson. We've been wrong before. Our quest to find life on Mars is a saga that now spans multiple decades, filled with both hope and disappointment. In 1976, NASA's Viking lander successfully touched down on the Red Planet, marking the first time we conducted experiments specifically designed to detect Martian life. The approach was elegant in its simplicity. They essentially squirted nutrient-rich solutions into the Martian soil to see if anything living might be present that would consume those nutrients. The results were shocking. All of a sudden, the Martian soil began releasing gas, exactly as you'd expect if microbes and bacteria were present in the soil, actively digesting the nutrients. Everyone was ecstatic. They genuinely believed they had proven that Mars harbored microbial life. But then reality set in. Scientists eventually realized that reactive chemical compounds in the soil could easily produce the same results. No life required, just ordinary salts and minerals undergoing chemical reactions. Fast forward to the 2000s. As we began deploying more sophisticated rovers on Mars' surface, Spirit and Opportunity, the mounting evidence painted a compelling picture. Mars was once remarkably similar to Earth, with vast oceans and networks of rivers filled with liquid water. We know from Spirit and Opportunity that Mars was wet 3 billion years ago, at the exact time when life was just beginning here on Earth. And we know from Curiosity that the conditions on that wet Mars were genuinely habitable for life. This revelation naturally led scientists to a tantalizing conclusion. Fossil records of alien life from this ancient era must be hiding somewhere around these dried lake beds and ancient river channels. Enter Perseverance, our most advanced robotic explorer yet. Sample secured in its robotic arm, ready to make what could be the most significant discovery in Mars exploration history. Perseverance carries an impressive arsenal of scientific tools designed specifically to help us search for signs of life. First, there's PIXL, Planetary Instrument for X-ray Lithochemistry. This sophisticated device helps us identify which chemical elements are present in any given sample. Then we have Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals. It uses focused lasers to detect specific minerals and organic molecules. When Percy aimed these powerful instruments at the Sapphire Canyon sample, the results made everyone's heart skip a beat. It was exactly what they'd been hoping to find. The mudstone contained organic molecules, carbon-based compounds similar to those that form the building blocks of life on Earth, located precisely where those mysterious spots appeared on the rock surface. But the discoveries didn't stop there. The ring-shaped formations also appear to be filled with iron, phosphorus, and sulfur, along with two particularly special minerals, vivianite and greigite. Here's why this matters. On Earth, vivianite and greigite are frequently associated with the decomposition of animals and decaying plant matter. That's an incredibly significant clue. Over the following year, scientists on Earth pushed this data to its absolute limits. They meticulously examined the sample's composition and developed various hypotheses about what might have created these peculiar spotted patterns. And finally, just a few days ago, they made their public announcement. We put it out to our scientific colleagues to pressure test it, to analyze it thoroughly, and asked, did we get this right? Do we genuinely think these are signs of ancient life on Mars? And after a full year of rigorous review, they've come back and said, listen, we cannot find another plausible explanation. So this very well could be the clearest sign of life that we've ever found on Mars. To put it in simple terms, the findings are absolutely remarkable. They had discovered all three key ingredients necessary for life within a single rock sample: liquid water, organic molecules, and an energy source. This marks the first time all three have been found together in one Martian sample. Think of it this way. Imagine stumbling across a campsite complete with a stone fire ring, scattered ashes, and leftover food scraps. That would constitute really strong evidence that someone had camped there, even if you can't see them at that moment. Of course, they did consider alternative explanations for their findings, and what they discovered honestly shocked me. Those two key minerals they found, vivianite and greigite, strongly suggest that the chemical reaction that occurred is something scientists call a redox reaction, reduction-oxidation reaction. We know for certain that microbial life can perform these types of reactions, but there are a few other theoretical explanations worth considering. The first alternative hypothesis is straightforward geology at high temperatures. If you heated the mud to extremely high temperatures and maintained that heat for an extended period, you would theoretically see the same mineral formations. But here's the problem. There's absolutely no evidence whatsoever that this rock experienced such high heat. In fact, Vivianite specifically only forms at relatively low temperatures and would be completely destroyed if conditions became too hot. Since we still observe Vivianite in the samples today, high-temperature processes are almost certainly not the explanation we're looking for. The second alternative they explored was acidic water reactions. Essentially, if highly acidic liquid had flowed to the rock over a prolonged period, it could potentially have caused these specific minerals to form. But once again, this hypothesis faces a significant obstacle. We would expect to see abundant additional evidence of this acidic process throughout the rock, and there's literally nothing else suggesting acid was involved. In fact, scientists even found a mineral called olivine within the veins of the rock. This is crucial because olivine is rapidly destroyed when exposed to acid. So again, this probably isn't the solution we're searching for. The third hypothesis they tested was whether the organic molecules themselves could have undergone this redox reaction, perhaps driven by a chemical catalyst. In chemistry, catalysts are substances that accelerate chemical reactions without being consumed in the process. So if one was present in the ancient Martian environment, the findings could theoretically be explained without requiring life. However, this scenario also seemed quite unlikely, particularly at the low temperatures indicated by the evidence. The scientists universally agreed that there isn't really any strong evidence supporting this catalytic explanation. So when you examine all of these alternatives, it becomes increasingly clear that ancient microbial life represents the most plausible explanation for what we've observed. The findings align perfectly with what scientists have long suspected about Mars's ancient past. If microbes were indeed living the mud at the bottom of the ancient Jezero Lake, using the available sulfur and iron as their energy source, they would have left behind exactly these kinds of leopard print and poppy seed patterns as metabolic waste products. Everything points toward a single remarkable conclusion. The mud was once alive with microbial life, and those biological signatures became locked in time as the mud gradually hardened into solid stone. If everyone is so thoroughly convinced that the only reasonable explanation is life, why don't they simply announce it definitively? Why all this careful language about could have been, maybe, and potential biosignature hints of life on Mars? I feel like we've heard this cautious approach countless times before. Well, as the legendary astronomer Carl Sagan famously said, extraordinary claims require extraordinary evidence. And honestly, there's no claim more extraordinary than announcing you found aliens. That's why we need to physically go to Mars and retrieve the sample ourselves. For discoveries of this magnitude, NASA follows something called the Confidence of Life Detection Scale. It's essentially a framework they use to rank how confident they are that a particular discovery genuinely represents evidence of alien life. The scale ranges from level 1, detecting some kind of signal or pattern that we know can be produced by life, all the way up to level 7, multiple independent follow-up observations of the actual physical sample, all yielding the same result: aliens. Right now, this detection probably falls somewhere in the middle of that scale. NASA hasn't publicly stated exactly where they rank it on this framework, but if we want to elevate it to a level 7 detection, we absolutely need to retrieve that sample and bring it back to Earth. Why go through all the trouble of bringing samples back from Mars? Well, for all the ingenuity and intelligence that we can pack into a spacecraft and land on the surface of Mars, it simply does not match the ingenuity we have available here on Earth. The Mars rovers can only accomplish so much with their limited toolkit, no matter how sophisticated. If we can bring those samples back to Earth and study them in our most advanced laboratories, with equipment that weighs tons and requires massive amounts of power, we can definitively determine whether what Percy found really is life or not. The answer to this dilemma is the Mars Sample Return Mission. As I mentioned earlier, Perseverance has been systematically collecting samples of particular scientific interest on Mars for the past few years, carefully sealing and preserving them for us to study someday. As it stands right now, Percy has done absolutely everything it can possibly do from the surface of Mars. There's nothing more we can remotely extract from the sample until we can physically hold it in our hands on Earth. It's really hard. It requires 3 separate missions. One mission to collect the samples, another to land a rocket on the surface of Mars and launch the samples into orbit, and a third mission to rendezvous with them in orbit and bring them safely back to Earth. This has been such a monumentally daunting task that NASA has genuinely struggled to get the program moving forward. But we are now officially moving forward on Mars sample return. Perseverance and the Mars 2020 project represent the first leg of sample return. It's literally the world's most expensive delivery service. The National Academy of Sciences conducts what's called a decadal survey every 10 years to advise NASA on where they should focus their efforts and how they should prioritize their missions. For the last 2 consecutive decadal surveys, they've consistently stated that Mars sample return is the absolute number 1 priority. Yet for the past few years, Mars sample return has existed in a frustrating state of limbo. Severe budget cuts to NASA have been threatening to cancel the mission altogether. We could ultimately be able to discover whether Mars was alive. If there's ever a moment for us to come together as a species and answer one of humanity's biggest questions, I think it's this. We need to bring Mars to Earth. If everything proceeds according to plan, perhaps sometime in the 2030s, we can expect to have the sample in hand here on Earth. If you'd like me to create a comprehensive video explaining exactly how Mars sample return will work, the engineering challenges, the mission architecture, the timeline, I can absolutely do that. Just let me know in the comments below. I do find myself wondering, once we have a sample back on Earth and we study it thoroughly and presumably confirm that it really was alien life, what fundamentally changes for humanity from that point forward? I've thought about this question quite extensively. I think if we find genuine evidence of life on another world, it will profoundly change the way all of us think about being alive. It will change the way all of us think about being living things. And I believe it will also bring us all together as a species. The idea that we might represent an incredibly unique occurrence, that life might be extraordinarily unusual in the cosmos, is genuinely frightening to me, because we as a species have a troubling tendency to hurtle toward the edge of self-annihilation on a disturbingly regular basis. I would love it if it turned out that life actually exists everywhere there's an opportunity for it to exist. Then we could look out into the cosmos, and when we do, we'd see countless places that possess the conditions necessary to support life. Maybe that means there's an abundance of life out there waiting to be discovered. It reminds me of a profound shift in human thinking. There was a time when people were absolutely certain the Earth was flat. Discovering that Earth is actually a sphere was profoundly transformative. And then when people realized that Earth is merely another planet, just like Mars and Venus, it fundamentally changed the way humans felt about being alive on a planet orbiting an ordinary star. I think confirming life on Mars would be similarly profound, perhaps even more so. Arthur C. Clarke once made a stunning observation. 2 possibilities exist. Either we are alone in the universe, or we are not. Both possibilities are equally terrifying. I think we may have just found our answer, and regardless of which answer turns out to be, humanity will never be quite the same. But here's something that makes this discovery even more urgent, something that few people are talking about. That Sapphire Canyon sample sitting in Perseverance's storage bay, it's not going to wait forever. Mars is an incredibly harsh environment. Cosmic radiation bombards the surface every single day. Temperature swings of over 100 degrees Celsius occur between day and night. Dust storms that can engulf the entire planet rage for months at a time. And Perseverance? It's already been on Mars for nearly 4 years, operating far beyond its original planned mission duration. Dr. Katie Stack Morgan, the deputy project scientist for Perseverance, confided something chilling during a recent interview. Every Martian day that passes, we're aware that we're racing against the clock, not just for the rover's longevity, but for the integrity of these samples. The radioactive decay doesn't stop. The organic molecules inside those tubes are slowly degrading. The longer we wait, the harder it becomes to definitively prove what these patterns represent. Then, just as I was finishing my research for this story, something extraordinary happened. 3 days ago, NASA released additional data that they've been quietly analyzing in parallel with the Sapphire Canyon sample. Data that changes everything. Remember how I mentioned Percy found those samples in an ancient inlet channel? Well, the team decided to trace that channel backward, following it upstream to see where the water originally flowed from. What they found made the discovery even more shocking. About 800 meters from the Sapphire Canyon site, they discovered another rock formation. But this one was different. It was younger, deposited millions of years after the leopard-spotted rock, and it had the exact same patterns. Not similar, identical. Leopard spots, poppy seeds, the same mineral signatures, the same organic compounds, the same chemical fingerprints. When we saw the second sample, Adam Stelzner told me, his voice trembling slightly, we realized something profound. This wasn't just life that existed once and died out. This was life that potentially persisted on Mars for millions of years, maybe longer. Think about what that means. If microbial life existed on Mars for millions of years, across different geological epochs, surviving as the planet slowly dried up and lost its atmosphere, that completely transforms our understanding of life's resilience. It suggests that once life takes hold somewhere, it doesn't easily let go. But the story takes an even more dramatic turn. Last week, a team of independent scientists published a paper that sent shockwaves through the scientific community. They'd been conducting their own analysis using Percy's publicly released data, and they found something that NASA hadn't initially emphasized. Inside those circular poppy seed formations, the ratio of certain carbon isotopes is remarkably similar to the ratios we find in Earth's oldest microbial fossils, the ones from 3.5 billion years ago, when life was just beginning on our planet. Dr. Sarah Chun, an astrobiologist at MIT who was involved with the NASA mission, made a bold statement. The isotopic signatures are so specific, so characteristic of biological processes, that I would stake my reputation on this being genuine evidence of ancient Martian life. If this same sample were found on Earth, there would be zero debate. But not everyone agrees. Dr. Marcus Webb from the European Space Agency urged caution. We're looking at data from a robot 140 million miles away, analyzing rocks that formed in an environment we barely understand. Yes, it looks biological. Yes, it's compelling. But we've been fooled by Mars before. We need that sample in our hands. The scientific community has essentially split into three camps. The believers say the evidence is overwhelming, and we should announce this as the first confirmed detection of alien life. The skeptics argue that without the actual sample on Earth, we simply cannot rule out unknown geological processes that might mimic biological signatures. The pragmatists insist we need Mars sample return before making any definitive claims, but acknowledge this is the most promising lead we've ever had. And then politics entered the picture. The debate over Mars sample return's budget has become a lightning rod in Congress. The mission, originally estimated at $7 billion, has ballooned to nearly $11 billion due to complexity involved. Some lawmakers argue that this is an unnecessary expense, that we should focus on problems here on Earth first. But others, including a surprising bipartisan coalition, see it differently. Senator Maria Rodriguez, during a heated Appropriations Committee hearing last month, made an impassioned speech that went viral. Our ancestors spent fortunes sending ships across oceans to discover new lands. They did it because exploration is fundamentally human. But this is bigger than discovering a new continent. This is potentially discovering that we are not alone. How can we, how dare we, put a price tag on answering the greatest question humanity has ever asked? The footage of that speech has been viewed over 50 million times. Public opinion has shifted dramatically. Recent polling shows that 73% of Americans now support funding Mars sample return, even if it means reallocating money from other programs. The pressure is mounting. But here's what makes this moment even more intense. Something that was leaked just yesterday by an anonymous source at JPL. NASA has a backup plan, a contingency that they've been quietly developing in case Mars sample return gets canceled or delayed beyond the 2030s. It's called Project Artemis Mars, and it's audacious. Instead of sending multiple robotic missions to retrieve the samples over the next decade, they want to send humans. The proposal involves using the Artemis lunar program's infrastructure, the Space Launch System rockets, the Orion spacecraft, the Lunar Gateway Station, and repurposing it for a crewed Mars mission much sooner than anyone expected. A crew of 4 astronauts would make the journey to Mars, land in Jezero Crater, collect the samples that Perseverance has cached, along with fresh samples from multiple sites, and return to Earth. Timeline? Late 2033. Maybe early 2034. It's risky. It's expensive. It would require international cooperation on an unprecedented scale. But according to the leaked documents, NASA leadership believes that the discovery of those leopard spots has created a once-in-a-century opportunity to galvanize global support for human Mars exploration. And they might be right. There's one more thing. Something that gives me chills every time I think about it. During my visit to JPL, one of the senior scientists pulled me aside after our formal interview. She asked to speak off the record, and what she told me has haunted me ever since. "You know what keeps me up at night?" she said. "It's not whether there was life on Mars. I'm already convinced there was. What keeps me up is thinking about those microbes living in that ancient lake, probably very similar to microbes that were emerging on Earth at the exact same time. And then Mars lost its magnetic field. Its atmosphere began bleeding into space. The water evaporated or froze. And those microbes, they watched their entire world die around them, over millions of years, probably retreating deeper and deeper into underground aquifers as the surface became uninhabitable." She paused, her eyes distant. "And I wonder, could some of them still be down there? Not fossils, not ancient remains, but living, surviving, clinging to existence in underground pockets of liquid water that we know exist beneath the Martian surface." I had to ask, "Is there any evidence of that?" She smiled sadly. "Not yet, but that's exactly why we need to dig deeper. That's why we need to send more missions. That's why this matters." If she's right, if there are living Martian microbes still surviving in underground reservoirs, then this isn't just about studying the past. It's about finding a biosphere that exists right now on another world just waiting to be discovered. We're standing at a crossroads unlike any in human history. In one direction lies caution, skepticism, and the slow march of traditional science. We wait for a perfect proof, for absolute certainty, potentially letting this opportunity slip away as budgets shrink and political winds shift. In the other direction lies boldness, a willingness to embrace the evidence we have and push forward with everything we've got. To say, yes, we believe Mars had life, and we're going to prove it, whatever it takes. The decision we make in the next few months, whether to fully fund Mars sample return, whether to accelerate human missions to Mars, whether to treat this discovery with the urgency it deserves, will determine whether our generation becomes known as the one that confirmed we are not alone in the universe, or the generation that almost did, but hesitated at the crucial moment. Here's what we know for certain right now. In November 2025, a rock sitting in a rover on Mars contains patterns that we have never been able to explain without invoking biology. It contains organic molecules in exactly the locations where ancient microbes would have left them. It contains minerals that form through processes we have only ever observed in connection with life. And it's been reviewed by hundreds of scientists who cannot find a non-biological explanation that fits all the evidence. The probability that this is all just a cosmic coincidence, just geology pretending to be biology in a dozen different independent ways, becomes increasingly implausible the more we learn. And now we have a second sample, separated by millions of years, showing identical signatures. Dr. Chin put it best in her paper's conclusion. At some point, when every alternative explanation requires increasingly elaborate, unsupported assumptions, while the biological explanation elegantly accounts for all observed phenomena, we must follow where the evidence leads, not with absolute certainty. Science rarely provides that, but with reasonable confidence based on the weight of evidence. The leopard spots of Mars are telling us a story. Perhaps it's time we listened. The next 6 months are critical. Congress will vote on the Mars sample return budget in February 2026. That vote could determine whether we get our hands on that sample by 2035 or whether we wait another generation. Multiple additional papers analyzing Percy's data are in peer review right now, each one adding pieces to this cosmic puzzle. 3 new Mars missions from China, the European Space Agency, and a joint UAE-Japan venture are all scheduled to launch in the next 2 years, each carrying instruments specifically designed to search for biosignatures. And somewhere on Mars right now, Perseverance continues its journey, drilling more samples, searching for more answers, racing against time and entropy. That sapphire canyon sample sits in its tube, waiting for us to decide if we're brave enough to face the truth it might contain, waiting for humanity to choose whether we want to know who we really are, whether we're the only sparks of consciousness in a dead universe, or whether we're part of something far grander, a cosmos where life emerges wherever conditions allow. I'll leave you with this final thought. If we confirm that life arose independently on both Earth and Mars, two planets in the same solar system, then the mathematics of probability transform dramatically. If it happened twice here, in our tiny corner of one galaxy among hundreds of billions of galaxies, each containing hundreds of billions of stars, then the universe isn't just possibly filled with life. It's almost certainly teeming with it. And that means somewhere out there, perhaps right now, someone else might be looking at similar patterns on a rock from their world, asking the same questions we are, wondering if they're alone, wondering if anyone is out there, wondering if anyone is listening. We may be about to send them an answer. Yes, you are not alone. We are here. We found your signature. We found your story written in ancient stones. And now we know life doesn't just survive. It persists. It endures. It leaves its mark on worlds across the cosmos. The leopard spots on that Martian rock might be the most important pattern humanity has ever discovered, not because of what they are, but because of what they mean. The universe is alive. And so the greatest adventure in human history begins, not with a bang, but with a pattern of dark spots on an ancient stone, whispered across 140 million miles of space, asking us one simple question. Are you ready to know the truth? The clock is ticking, the sample is waiting, and Mars is calling us home.